Hi, this is section 1-2, and this is on order of operations. This is definitely a section that I have to test and quiz you on without you using a calculator. And the reason for that being, if I let you use the calculator will always put things in the proper order, whether you know how to or not. So letting you use the calculator really doesn't tell me if you understand this at all, okay? So one thing I need you to understand up front, when you're practicing these problems in the book, when you take quizzes or tests over this material, I will not let you use your calculator. So please, when you're at home or wherever and you're practicing this, please try without, because all you're doing is you're hurting yourself if you just basically cut corners and use your calculator, because then you're not practicing what you need to be practicing. So let's review order of operations. I know you've been taught this definitely in grade school, probably starting as early as 5th, 6th grade, okay? When you have expressions and you're going to be asked to evaluate the expression, there's a certain order you have to do it in to get the answer correct. And you want to follow this order. If there's parentheses, always do what's in parentheses first. We always have to take care of any exponents we see after we have parentheses. You always want to divide and multiply in order from left to right next. Do all the multiplying and dividing in order from left to right after you've identified parentheses and dealt with exponents. Adding and subtracting comes next, again in order from left to right. Okay? Another thing I wanted to kind of just a little reminder with parentheses. Parentheses can look in several different ways. They could look like this, which you've normally see, or they even could be in bracket form. So parentheses can have different looks to them. Okay? It is really, truly important that you do things in the proper order. And I just want to give you a quick example of why, okay? Because you might be like, who cares what order I do it in? Why does that matter? Okay? Well, here would be a perfect example of why the order matters. I'm just going to make up a problem here. Like, let's take something like this. Okay? Let's just suppose I did not do this problem in the proper order. So I'm going to do it in red because this is wrong. Okay? Suppose I just decided to do 20 minus 4 first and got 16. And then I decide to take, well, since this is 16, I now have to square 16. I now need to take 16 times 16. And if I'm doing my mental math right, 16 times 16 is 256. Maybe I should check that on. Well, I'll just do it up here. I guess I don't need to check it on my calculator. 6 and 6 is 36. That's 96. 256. Okay? Well, that's not the right answer, and it's because I did not do this in the right order. The correct answer to this would be, remember, if you follow the proper order. Now, let's look at what I did wrong here. I didn't follow the proper order. Do you notice how I subtracted before taking an exponent? Well, if we go back to the previous slide, I always have to deal with exponents first before I add or subtract. So that's the rule I just broke if I decided to do the problem like this, which, of course, is not correct. I have to do the exponent first. 4 squared is 16. I really have, let me write this down, I really have 20 minus 16, and that equals 4. So there's the correct answer, and you can see how far I was off from the correct answer by just not doing the problem in the right order. So order operations, very, very important when you're evaluating an expression. When you're working these out, I want you working down on your paper. I don't care if it's me teaching, Mr. Keller or Miss Nettleman down the road, or you go on to college. Your professors at that level would want to see your work working down. So I'm just going to work on some examples with you from the text, and we can work through these together right now. So if you want to go ahead and look at problem on page 10, if you want to look at problem number 8, you'll notice the directions for this are to evaluate the expression, which basically means get the answer. But the key thing is I got to do this in the proper order. So when I look at number 8, I'm seeing, okay, now let's think back. I got to do this in the proper order, and here is the proper order of operations. Well, let me see. Do I have parentheses? No, I don't, so I don't have to worry about that. but I do have an exponent. I should do the exponent first. So I got to do 5 squared. 5 squared is 25. So now I have 1 plus this just turned into 25 divided by 50. Okay, so now I have adding and dividing. Well, when I go back, the dividing has to take priority over the adding. So I should now divide next. 25 divided by 50 is half. 25 out of 50 is a half. So I really have 1 plus a half, and that's 1 1/2. That's what the work would look like, and we did it in the proper order. Okay? Number 10. I have 4 to the 3rd power divided by 8 plus 8. Well, I got to do it in the proper order. The exponent takes first priority. 4 to the 3rd power. 4 times 4 times 4. That's 64. So I have 64 divided by the 8 plus the 8. 64 divided by 8 comes next. Dividing always would take priority over adding on my scale. Let me go back. There you see it. Dividing is a higher priority than adding. So I got to do the 64 divided by 8 next. 64 divided by 8 is 8, and then 8 plus the 8 is 16. So number 10 would work out to 16. In 28, you see a fraction bar. Let's talk about a fraction bar. I got to go back a few slides to do that, okay? Because we have the scale here of order, parentheses first, exponents, divide, multiply next, add, subtract next. If you have a fraction bar, there's special rules to a fraction bar, okay, that we need to cover. Let me get this out of the way. When you see a fraction bar, like here's an example, 10 plus 6 over 2 plus 4. A fraction bar works like parentheses, okay? And what I mean by working like parentheses, or it acts like parentheses, what it really means when you have a fraction bar is that you have to do everything in the numerator first, do everything in the denominator second, and you can't divide until the very end. That's why I put here divide last. Okay? So I can't just do like 10 plus 6 is 16 and 16 divided by 2. If I do that, I've screwed up. I got to do 10 plus 6 is 16 on top. I got to do 2 plus 4, that's 6 on the bottom. And now I can try dividing. Now 16 divided by 6, if we think in our heads, 6 does not go into 16 evenly. But here's what we could do. We could say, let's see, what number does go into 16 and 6 evenly? Well, I know 2 does. 2 divides into 16 8 times. And 2 divides into 6 3 times. That's where I'm getting 8/3 from. 6 will not go into 16 evenly, but 2 will go into 16 and 6 evenly. I can write 8/3. Okay? So when you have a fraction bar, we must do everything in the numerator first, everything in the denominator second, and then divide at the very end. And that would then take me to number 28. Because when you look at 28 and they're asking you to evaluate this, we see a fraction bar. We got to deal with this properly. I can't just divide first. I got to actually divide last. I got a fraction bar. So let's take x, and which is 7, and let's replace 7 in for x. Let's do that. We're going to replace x in for 7. So we really get 9 times 7 plus 4 in the numerator. Remember, the numerator is the top of the fraction. And we have 3 times 7 plus 1 in the denominator. The denominator is the bottom. Well, we can't divide right now. We got to do, remember, fraction bar means we basically have parentheses here and parentheses here. We got to do what's in the parentheses in the numerator and the denominator first, divide at the end. Let's do that. 9 times 7 on top is 63, and 63 plus 4 is 67. So the numerator, I have 67. In the denominator, 3 times 7 is 21. And 21 plus 1 is 22. So I have 22 in the denominator, and that's 67 over 22. Now let's think. Does 22 go into 67 evenly? I know it doesn't. 22 times 3 is 66. And let's see. I know I can divide 22 by 2. I can't divide 67 evenly by 2. 67 is an odd number. And I can divide 22 by 11, but I can't divide 67 by 11. I can't reduce that. So this is in lowest terms. 67 over 22 is in lowest terms. So remember, I'm just going to put a little star next to that. Remember, when you see a fraction bar, you got to do everything in the numerator and the denominator first, and you have to divide last. Okay? Actually, this video isn't as long as yesterday. I'm happy about that. It's only a little bit over 10 minutes. I know the one before was 20-some minutes. I'm sorry about that. I don't try to make my videos too long, okay? But I think that will get you going on today. I would say as a whole, this is a review, but the key thing, and again, I don't know what your previous teachers made you do. I hope they made you put your calculator away for this, but if they didn't, I'm telling you, I am, okay? So we need to show that we can do this without a calculator. All right, I'll see you tomorrow.